If you want to do any statistical analysis, unless you are not depending on the data, definitely we are not able to do the statistical. Univariate data are obtained only one characters. You must remember only one characters or one variables. We are not separating individually. We need to study for the two variables. Hello everyone, a warm welcome to one and all. I am Natesh, lecturer in Commerce, Vidhyaashram First Grade College, MYSURU, the Temple of Excellence. So, in this session, we are in the Unit 1, Section 1, Business Statistic, third semester BCom, Statistical Data and Descriptive Statistics. Okay, so today my agenda is the meaning of statistical data and descriptive statistic, what it is exactly, and the nature and classification of data, about the nature and statistical classification of data, and the measure of central tendency. You have to know the definitions of the measure of central tendency, and in arithmetic mean the properties and application where exactly we going to use the arithmetic mean. Moving forward, so the meaning and statistical data, descriptive statistic, what exactly meaning? The statistical data. If you want to do any statistical analysis, unless you are not depending on the data, definitely we are not able to do the statistical. The statistical is completely depending on the data, whatever which is related to your business, which is related to your transactions. The statistical data, the data are collected because any problem or any problem, if you are trying to take any planning, if you are trying to take any decision, the data is very important. The statistical is the latest tools which is everywhere. They are implementing a statistical tool because want to find out the best solution, how it is the result, how you can forecast, all this based on the statistical analysis only. We as a businessman, they are taking many day-to-day life, they are taking too many decisions, collecting and generated by statistical in process of statistical observation and statistical data processing. The data what you are collecting, which will go further process, there are number of process, okay, and you need to go for the process, fulfill the process, okay, the statistical activity, the statistical observation frequency, what you are observing, what kind of data which is related to statistic, to take a decisions making, all are relevant in the statistical data. And descriptive statistic, what exactly meaning here? In this course, you will learn how to organize and summarize and interpreting the data. Data, whatever you collected, you have to organize properly. Now you will think which is my relevant, which is my not relevant data. So everything you need to organize and summarizing, which is giving a one statement or using a pictorial, or you are using a tabulation format. We need to present the data, not only organizing, not only summarizing. We need to classify the data, we need to interpret the data, we need to tabulate the data, okay. So organizing and summarizing data is called for descriptive statistic. The descriptive statistic, I think you got a clarity. Moving forward, the nature and classification of data. See, the nature and classification of data, there are plenty of data we can collect based on the characteristic, based on the scale of measurement, based on the orders, based on the sequence, the source, the data, how you are collecting, how it is connected to your business, okay. So based on the scale of measurement, we will study the data. One is for nominal data and ordinal data, interval data, ratio data, okay. If you take example for characteristic, univariate data, bivariate data, or multiple variate data, there are different types of data. Now quantitative data, qualitative data, there are too many types of data which is available. So each and every business, they are depending their unique data, whatever it is required to take a decisions or solve. So nominal data means very simple. So nominal means any object, you are assigning one numbers, you are assigning numbers, which is called for nominal data. Example here, see, male I can write 1, Female I can write 2. So this is actually when the objective or characters we are labeling as a number, that is a nominal data. Okay, the nominal scale is used for assigning a numbers. Very simple here, assigning a number. See, in a family, how many members? If elder, younger, so we can use for number to assign. The same thing, male or female, we can assign for 1 or 2. A good, bad, excellent, satisfactory, we can assign for numbers, so that everything easily we can recognize, we can identify what kind of data it is. So using a nominal scale, because it is very clear the scale what we are using to identify the nominal data. So because number we are using as identification of individual unit. So here see one objective, or here also you can find out female is also one identification. So when we are assigning a data numbers, so easily we can identify. So for example, the classification of journals according to the discipline they belong to, so maybe consider as a nominal data. See, there are different in the textbook, the content, they are assigned one page number. So easily you can identify, or you can locate the where I want to exactly want to go for referring. Okay, so when you are assigning, so same thing, whenever you are assigning, wherever you are finding the numbers in front of the objective, obviously which is coming under the category of nominal data. So numbers assigned describe the category, the numbers represented only the name of the category. Moving forward for next data, ordinal data is nothing but ordinal, we are writing in the order. Okay, now if you take example in the class, okay, when you are assigning a rank, first rank, second rank, third rank, whenever you are assigning a rank, the difference will be equal. See, if you take example for first rank and second rank, so distance will be 1. Okay, so when you are assigning, easily you can using a ordinal data, we can assign the first rank, second rank, third rank. Okay, so here if you take order wise, how you can identify the person using the ordinal order wise, first order, second order, third order, like this ranking. So it indicates the ordered or graded relationship among the numbers assigned to the observation made. What exactly we are observing the data, when we are assigned a data, so using a ordinal numbers rank we are using, so easily we can identify, right? That's what these numbers cannot rank the different category having a relationship in the definite order, because the first rank they scored much better compared to second rank. So obviously when we are giving a rank, so that we can identify very easily who is in the top, who is in the bottom, everything we can identify. For example, the study of responsiveness of library staff, the researcher may assign, because when you are studying the examples like response of library staff, there in the library there are too many readers, they are going to refer the textbook or journals. Okay, so how they are responding, now researcher want to get to know the information how they are responding. So they are assigning 1 numbers for indicating poor, 2 numbers for indicating for average, 3 numbers indicate for good, so 4 number indicate for excellent. So anything you can go for modification. For example, excellent we can assign 1, poor we can assign for 4, according to rank we can assign. Okay, so obviously after going a supermarket, shopping mall, so after bill generating, they are asking to press button, first rank, second rank, a good, bad, excellent. Okay, so satisfactory, that is one kind of they want to get information or feedback from the customers. So numbers whatever it is assigned here, 1 2 3 4, so on. Okay, so which is a set of ordinal data, because order wise we assign the data. That's what easily we can identify. Indicate the 4 is better than the 3, or 1 is better than 2 3 4, 2 is better than 3 4, like that, so on we can assign the data. Now ranking, the ordinal data show the direction of the difference not to exact amount of the difference. So the difference what we are getting, see, I told you first rank, second rank, third rank, equal distance. When we are comparing first rank between the third rank, so the difference will be 2 we are getting. So moving forward for the next data. So interval data, it is clearly it is specified interval. Interval means what? See, 0 to 10, if you take example, the 10 difference. If you taking example for 10 to 20, 10 difference, equal difference we are getting. See, if anybody is lying on the 5, they are lying on year 0 to first class. Second class, suppose if you are taking 15, they are lying in the second class. Now class interval, it's nothing. Interval, each class, how what is the width? Okay, so interval data are ordered category of data, and the difference between the various category, each difference we are getting 10 10 10. So the equal distance we are able to find out. In case if it is not equal distance, okay, now density factors we are using in the statistical method. So our equal measurement, for example, we can measure the IQ, because in the classroom you need to check IQ. Okay, exactly the student what percentage they are having. Okay, so IQ intelligence questions of group of children, after assigning the numerical value of IQ each child, the data can be grouped with interval 10, 0 to 10, 10 to 20, 0 to 10, 10 to 20, 20 to 30, and so on. So the rank, how many classes will be there, we can extend. In this case, 0 does not mean, because which is not coming under the one specific class. But if you are writing 0 and 10, lower limit and upper limit, then it is considered as a class intervals. Absence of intelligence and children with IQ 20 are not double intelligent than the children with IQ 10. See, because each and every person, they are having a different level of IQ. Each and every student, they are having a different level of IQ. So obviously we need to identify the exact class where they are coming. Moving forward for the last data, the ratio data. The ratio data is nothing but actually giving. So for example, if you are taking 10 divided by 2, or if you are 10 divided by 2, if you are getting 5 value, now ratio is a equal dividing, right? So ratio data are the quantitative measure of variables of terms of magnitude. The ratio data, we can say that one thing or twice or thrice. So 3 times much better, 2 times is much better. So which is and all, it's coming under the ratio data category. So for example, measure of involving weight, 1 kg, one family they are purchasing 10 kg of rice. Okay, if one more family, if you try to compare, I will purchase twice what you are purchasing. That means which is coming under the ratio data. So distance also and price, etc. So moving for the forward for the characteristic whatever which is related to the data. So how we can study here the data with reference to number of characteristic. In the characteristic, we going to study for 3 characters. One is, see, the data can be categorized on the basis of number of variables. How many variables are keep on vary? If it is one variable, we can say it is a univariate. If it is 2 variable is there, means we can say it is a bivariate. If 2 or more variables are there, means multiple variate. So like this we can classify univariate, bivariate, multiple variate. And the data, we as a statistician, we need to analyze each and every data. You have to identify what kind of data it is. Okay, now univariate data, it's clear. Univariate data are obtained only 1 characters. You must remember, only 1 characters or 1 variables. Okay, so for the observation, for example, the performance of the student is given in the class, or the performance level it's given in the class. Go for the next. Univariate, this type of data consists of only 1 variable, 1 character, only 1 variable. You can see this example, you can understand there is no two variables, only one variable, height only they took for considerations here. So this analysis of univariate data is thus simplest form of analysis, because when you are dealing with the data, you need to locate, identify and classify. It is your responsibility as a statistician. So if you know how to identify which kind of data, so it is very easy. Since the information deal with only one quantity, the change, only one quantity will be changed. This is called a set of data, one variable set of data, or you can say, if you are writing, you can say in the discrete data. Okay, so it does not deal with the causes and relation. If you are taking height here, assume it is a x and y is a weight. If you take an example, that is, you need to find out the relations here. But in case of univariate data, we are not finding any relations. Okay, so the main purpose of the analysis is to describe the data and find pattern that exist within it. The example of univariate data, it is an example for height. Height you can say separately, you can write weight, or male you can take example. Only one variables you can take. Moving forward for bivariate data, it is bi means two variable, two characters when we go into study. Okay, so easily you can identify there are two elements, two characters or two variables. So bivariate data result when instead of one variable, in the univariate we studied only one variable. Okay, in this case two characteristics are measured simultaneously. We are not separating individually. We need to study for the two variables. Okay, for example, height along with the weight, okay, of the 10th class student, 10th class student, height and weight of 10th class student. Obviously it is coming under the category of bivariate data. So this type of data involve two different variables, because two different variables we are able to find out now. Okay, so the analysis of this type of data deal with cause and relation. Obviously there is, if the sales one kind of variable and advertisement is one kind of variable. If advertisement you are spending more and more, obviously you can expect the sales. So it is a cause and relations you can able to identify. The analysis are done to find out the relationship among the two variables. For example, bivariate data can be temperature and ice cream in the summer season. See, the Celsius increase, obviously the sales also increase. So the cause and effect, obviously, which is interrelations, right? So moving forward for next one. So then under nature of classification of data, third characteristic is a multivariate data. Multivariate data means, till now we studied one variable, that is uni, and two variables bivariate. And if you are taking more than two or three variables, when we identify, then it is called for multivariate data. Multivariate data consists of observation on three or more characteristics. For example, when we are studying for, when the government of India, they are conducting a census, they will collect the information which is related to family complete income, size of the family, how many members, how many are dependent, how many are independent, how many of them are government employee. So all kind of data they will collect, no? So like this, the family size we must know, and income and the saving of metropolitan. Here in this example we took only for three variables: family size, income, saving of metropolitan city in India. Okay, moving forward, classification of data in the multiple variate. So when the data involve three or more variable, it is categorized under the multivariate. Now we got clear idea. So for example of this type of data is supposed to advertiser want to compare to the popularity of the 4 advertisement on website. See, when we are comparing with the advertisement factors, okay, then their click rate could be measured for both men and women. See, when website they are giving open link, open communications between the consumer coming under category of men as well as women. How many men they click, how many female women are click. So easily I can identify the relationship between the variables can be examined by the individual company, those are providing the opportunity. It is similar to bivariate but contain more than one dependent variables. Okay, the way to perform analysis on this data depend on the goal to be achieved, because whatever the data you are collecting, there is one specific objective to fulfill your objective, to achieve your goal. So all the data whatever it is required, you according to your requirement you going to select. Some of the technique or regression analysis is the best example for multivariate data. Okay, so path analysis we can do it, and factor analysis and multivariate analysis of variance. Okay, or you can say MANOVA. Okay, these are different analysis are using in the statistical. Okay, moving forward, so after we are getting a much more idea about the data. Now moving forward, the measurement of central tendency. The central tendency means what exactly? How we can identify this kind of data or problem connecting with the central, measuring a central tendency. You need to measure the set of the data, getting an average or one numbers you are expecting. The measure of central tendency can be term with define the central value, because the set of data, for example X series data is given. Okay, so using a different numbers we are not able to get one value. So for that reason only we need to get central value. What we will do, we will take the sigma x. Okay, after dividing sigma x, we are dividing into number of item, how many numbers. Okay, so that will it will give you the central value or central data. Okay, so there are three parameters by which we can measure central tendency. In most of the commonly businessman they are using, okay, most frequently we are using mean, media, mode. So when we, at the time of mean, media, mode, which is coming under the measure of central tendency, we will study in depth in each and everything. When we are solving the problem, you will get much more idea. And the central tendency examples, the measure of central tendency is a value, because the set of value whatever it numbers is given, finally we need to get one value. Okay, so that represent a central entry of the data set. The data set, one set of data, two set of data, whatever it may be, it will keep on varying. So central tendency of the data can be calculated by measuring mean, media, mode of the data. So there are three different measuring of central tendency: mean, media, mode. So each and everything we will study in depth. Moving forward, so mean of data is a set of numerical value in the arithmetic average. Okay, the data value in the set. The set means what? Each set having a different numbers, right? Now x series set 1 2 3 4, like this one set. If you take y series 4 5 4 3 3 2, this is one kind of set. Finally we need to get one value, one answer. It is found by adding all the value, adding all the value, so divided by number of value. How many items? For example, first set we are able to identify 4 numbers, 1 2 3 4. Okay, so after adding all this we will get divided. You have to divide number of value, how many numbers we are able to identify here. Okay, the simple formula to find out the mean, arithmetic mean, sum of all value in the data set. Each set we need to take the summation. So divide by the total number of observation. Oh, in this first set, how many numbers we are able to identify? 1, 2, 3, 4. So divided by 4. Are you getting? Okay. So next, the classification of data under the mean of the sum of set of value divided by the number of value in the set. The notation for the mean of the set of value in the horizontal, either you are writing horizontal or you can write vertical. Okay, so anything if you do, the answer will be same. Okay, if you try to apply the formula carefully before what we studied here, see the sum of the all the value, this formula we need to x1, x2, x1, x2, x1, x3 till xn. How many set of how many numbers we are having divided by numbers, total numbers. And property of arithmetic mean, we must get a more clarity on the properties of arithmetic mean. What exactly? When arithmetic mean means we are able to recall x bar is a symbolically represented. In case of discrete data, we are writing x series. 1, 2, 3, 4. Okay, this is a number. You can take any example. Now, and the formula is sigma x divided by n. Sigma x. Now, from the x series, if you are taking total, okay, how much you are getting? 7, 9, 10. You are getting 10. Now, if you try to solve this using a formula x bar 10 divided by how many numbers here? 1, 2, 3, 4. 4. Okay. So after dividing, what we are getting? Arithmetic mean we are getting. So simple. Here we are familiar with ourselves with some important properties of arithmetic mean. The first one, how we can identify in symbolically x bar is a arithmetic mean, right? So in the arithmetic mean of n observation, how many observation in this case? 4 observations. Okay. x1, x2 you can locate here. This one x1, x2, x3, x4. Okay. So till xn. So in case till x, then x1 minus x bar. So directly we can find out the variation. So we can find out the using this formula also we can calculate the mean of n observation. In this set of data, how many numbers are there? Okay. So x1, x2, x3, x4, xn till xn. X bar is each observation increased by y. Suppose in case of y, what we are doing? In case of x bar y, we are adding. In case of minus subtraction means we are trying to minus. Okay. So in this case, the mean of n observation x1, x2, x3, x4 till xn. So xn, x bar is each of observation increased by y. In case of increasing means adding, decreasing means minus. So the mean of new observations will be x bar plus y. The mean of n observation in the set of data x1, x2, x3, x4 till xn. So x bar, if it each observation or decrease means minus you have to write here. Decrease minus, increase plus. In case of multiplications, so the mean of observation, n observation is given here x1, x2, x3, x4 till xn. X bar, how you can find out here? Observation of the multiplication means very simple. So y multiply into arithmetic mean x bar. Okay. So the mean of n observation also given, but they are asking to find out dividing means the property, it is very simple. X bar divided by n, if you try to do, you will get 0, non-zero value. And all the observation in the given set of data have a value y, say y. Arithmetic mean also y. So under arithmetic mean application, where exactly arithmetic mean is used or applied. Okay, arithmetic mean is taken out for the sequence, that the arithmetic sequence. The arithmetic mean is the easiest and widely used measure of calculating the mean. Everywhere the arithmetic mean is commonly they are using. So here there are different here where exactly the application part it is applied. It is used to algebraical treatment because algebraical it's a very it is clearly we can say it is a mathematical concept, and it is used to calculate the average score of sports such as cricket. See, average score, they played for 3 matches or 4 matches, we need to get one value, right? So in that case also we can take if you take average sale, average demand, everywhere we can use the arithmetic mean to get one central value. And it is also used in mainly diverse field, like where exactly we can use apart from this business, economic, anthropology and history, and even so many area they are using arithmetic mean. It is also used to measure the average temperature of the earth of the measure globe warming. So because average temperature we want to find out using 5 years data or 10 years data, we need to get an average, okay? So there also we can use arithmetic mean. It is also used to measure the annual rainfall of a particular area, annual rainfall, city to city, state to state, you can calculate average value. And here the majorly when we are trying to calculate arithmetic mean or media, we need to remember there are two set of data is coming. One is a discrete data, how it is looking. The discrete data can be classified into two category. One is group data, there is no observation, there is no frequency. When you are not able to identify the frequency, which is coming under the ungrouped data. Ungrouped data, here some examples are, a few examples are given here. X series x1, x2, x3, if you add together we are getting sigma x is 100. Now using this sigma x, we need to find out the arithmetic mean. X bar is equal to sigma x divided by n. 100 divided by how many observations here? 4. Then arithmetic mean we are able to get here 25. Okay. And in case of group data, when we call it as a group data, obviously we need to find out there is any frequency. In this case, frequency is there, means we call it as a under discrete data. It is a frequency when we are identified. So obviously the formula is slight change. Okay. So only what we are doing, so sigma x, instead of sigma x we are adding just for frequency. Okay. So x into frequency multiply fx. If you multiply, you are getting this value. After taking the summation of all this, now you can able to apply the formula sigma fx divided by n. Why we are writing n? Because in this problem, in this group data, frequency is given, means always we need to write in capital letter N. So that's what we will write here, capital letter N. After simplification, we are getting x bar is equal to 25. So under continuous data, I told the data we classified the discrete series, under discrete series, group data and group data. So again, second category of data here, continuous data. So always whenever you are doing a continuous series problem, always you have to remember, so which is a continuous series are having a frequency is 100%. Okay. So always grouped only, you have to treat as a group data. Why? Because in the continuous series frequency is compulsory is given. Okay, observations is given. So here inclusive data and exclusive data. In case of inclusive data, we supposed to convert for exclusive data. So here class interval, in the class interval we can write ci. Okay, in the class interval, when they are given inclusive data, okay, now we have to convert into exclusive data. So the class interval, how it is given, open limit and upper limit 0 to 34. Now whenever the first class upper limit is not carry for the second class or lower limit, so then it is easily, I can say it is a inclusive data. Because why? Once again I am repeating, 0 to 34. The upper limit which is not carry for the second class as a lower limit, then it is not coming under the exclusive category, which is a inclusive category. There are the 4 classes are given: 0 to 34, 35 to 39, 40 to 44, 45 to 49. So each class are having a frequency. If you take together, we are getting capital N is equal to 6. Now how we can convert into exclusive? Very simple formula. Class interval is already given. How we can convert exclusive? Lower limit minus 0.5, upper limit plus 0.5. See, if you minus, you will get 0 minus 0.5. If you add 0.5, we are getting 34.5. So same thing we can do for all the classes. Subtract 0.5 from the lower category, add 0.5 for upper category, then easily we can go convert for exclusive data. Once we converted the exclusive data, now we need to locate the midpoint in this. Midpoint means lower limit plus upper limit divided by 2, because we are able to identify there are two numbers, no, a lower limit and upper limit. So lower limit plus upper limit divided by 2, in the first class we are getting 17. Second class, lower limit plus upper limit divided by 2, we are getting 37. So like this, third class, lower limit plus upper limit divided by 2, 42. So on it is going on, how many classes will be given. So once we getting in the mid fact, we call it as a X series. Okay. Now once we are getting a X series value, now we need to multiply with the respective frequency. So f into x we need to do. Why? Because the formula is having here sigma fx divided by capital letter N. So if you multiply 7 into 1, 17. 37 into 2, we are getting 74. So 42 into 3, we are getting 126. And 47 into 1, we are getting 47. If you take together summation of all the fx value, 264. Now finally we try to apply the formula sigma fx divided by capital letter N frequency total. So 264 divided by 6, if you calculate, we are getting arithmetic mean is 44. Moving forward for next, continuous data, always group data. When exclusive data is given, we don't have any process to convert for the next process is not required, because directly I told you in the class interval, when lower limit and upper limit, first class lower limit 80, upper limit 100. When upper limit is carry for the next class as it is, then there is no conversion is required. Conversion is not required. So in this case, directly we can take the midpoint. A very simple formula I have written here. Lower limit plus upper limit divided by 2, if you do, you are getting the midpoint, which is treated as an x. If you multiply with the x into frequency, we are getting fx. If you take all the totals together, some sigma fx we are getting. So after applying this formula, we are able to identify the arithmetic mean. Calculation value is 1000 to 90. So there is one more examples here. So age of 13 job application, example of mean computation. The formula is very simple. Here the x value is given and frequency is given. Okay, so all this 30, here this frequency is not given in the sense. Here the frequency number of applicant, the serial wise it is given. Here frequency, okay. Now directly what we are doing, age is considered as an x. We don't want to get confused here, because see sir, there are two set of data is given. One is x I can treat, one more I can treat for frequency. Not like that, which is a serial number. But the age what it is given in the question, we have to treat it as an x value. Now the mean value I told you, x1 plus s2 plus x3 till xn. All the numbers, 13 numbers are given. Take the total together, we are getting 318. So divided by 13 application. If you divide, you are getting 24.5 is an mean value. Moving forward for the next questions. the height of 10 learner are measured in the centimeter to obtain the following data set is given. So here the following 10 learners data set is given, okay, and they told one more thing, after we include one more learner in the group who is especially tall at 1 centimeter, especially tall means we need to subtract. So compare the mean and median of the height of the learner before and after 11th learner was included. We'll try to go for next slide. So calculate the mean of the 10 learner. So whatever the data is given in this question, we will take the summation together. Divided by how many learners we have? We have 10 numbers. If you divide after taking all summation, we write here sigma x divided by, if you try to apply this formula, we are able to get a mean value 155.9 centimeter. So there is one more information is given. After we include one more learner, means 10 plus 1, 11 learners. So who is exceptionally tall, 180 centimeters. So in this case what we'll do, the same total whatever the 10 learners total what we took here, so minus 181 if you try to do, we are able to get a mean value 155. Why? Because minus, because they clearly specified exceptionally. From this we say that average height change by when we introduce the outlier value, the tall person to the data set, tall person to the data set, because all the 10 learners are normally height, normal height, but one person extraordinary, right? That's what. The second question, the find the mean from the given data, find the mean from the given data. So the data set is given here. Now if you take the x series, the total all together we are taking, we are able to get the total is 372. Okay, now how many members are there here? There are 13 members. Now 13 if you try to divide, see, so finally we are getting arithmetic mean value something, mean value we are getting. This is just for examplation. Now in the next class you have to answer how much you are getting, calculate and tell me. Thank you, keep on watch for next session.